Alright, for this video we're going to go ahead and group together the following three examples into one video because they are very quick. So, to do this we will just compare the top and bottom degree. So, to start this off, we're going to use the method of dominating terms. So I'll go ahead and put a little dt over my equal sign just so that as a reminder to myself and a message to whoever's reading or viewing my work what I was doing here. So I'm using dominating terms to say that this limit on the left has to be the same thing, has to be equal to, well, the ratio of the dominating terms. In the numerator, x cubed wins, so x cubed, and in the denominator, negative x squared. Make sure you bring that sign or coefficient, whatever it is, with you. Don't just grab x squared, because this will actually, this sign here, the sign can actually impact things depending on the specifics. So in general, the sign or the number cannot be ignored. So in this case here, once we simplify this, we're going to see that we have negative the limit as x goes to infinity of x. Well, seems kind of silly, but this question right here is literally saying, what does x do as x goes to infinity? Well, the answer to the question was in the question. If x goes to infinity, x goes to infinity. So this has to be equal to negative infinity because of that sign that we grabbed. So in fact here, the conclusion is, like our pattern that we're trying to develop, is if the top degree is greater than the bottom degree of our polynomial, then the limit as x goes to, well, I'll just say equals plus or minus infinity. It depends on whether or not there are signs, whether or not you're going to negative infinity, things like that. Okay, so, but it will be infinite, nevertheless. All right, next example here, example 3, we're going to do the same thing. Equals dt, the limit as x goes to positive infinity. And we're going to look at our dominating terms. In the top, we've got x to the fourth. In the bottom, we've got 2x to the fourth. So the degrees of our two polynomials are equal, 4 and 4. So if we simplify this, we can just get rid of the x to the fourths altogether. And then what we're left over with is really just 1/2 and the limit of that. But since there's no x's in this expression, we've learned that the limit of a constant is the constant. So this is just 1/2. And again, this is a common feature. If the top and bottom degrees are equal, then the limit is the ratio of the leading coefficients. And then we already did one limit like this, example 1, but let's just make it complete so that we can see all three possible cases for the limits at infinity of rational expressions. This limit as x goes to infinity, by dominating terms, we have negative x squared in the top, x cubed in the bottom, and this is going to be equal to, well, this simplifies down into negative the limit of 1 over x. 1 over x, as x goes to infinity, goes to 0, and there's no such thing as negative 0, it's just 0. So, the third option is the bottom degree is greater than the top degree, in which case the limit is equal to 0. So, top degree bigger, plus or minus infinity. Top and bottom are equal, ratio of the leading coefficients. Bottom degree bigger than the top degree, limit is 0. I will go ahead and just say, really briefly here, that this works for rational expressions. It's not that dominating terms can't be used for expressions that are not dominating, or sorry, that are not rational expressions, but you have to really think about what does it mean to be dominating. In the case of rational expressions, dominating, which one has the dominant influence, can easily and readily be checked by comparing the degrees of the two polynomials. But if you're taking the limit at infinity of something that isn't a rational expression, that means you either don't have a polynomial at all, or you have something that's a polynomial but something more than a polynomial. Maybe like a polynomial plus e divided by e or something like that. In which case you have to really think about what does this mean. So we'll do a separate video on that. For now, just this comparing of degrees only works for a polynomial divided by another polynomial.